My name is Andreas Hermeling. I'm with Ecofys at the moment sitting in the Berlin office. So the broadcast is from Berlin, so to say, in a cooperation with Spain. I'm going to talk about a project that we, as Fernando already pointed out, together with several partners did for the European Commission. The project was coordinated by Ecofys. I was the project manager, and in principle, I think it was the major project for the European Commission in order to elaborate also their own plan on how to implement the requirements on nearly zero energy buildings, which we find in the European Performance of Buildings Directive. The project had several elements that Fernando pointed out, and this is also reflected in the table of content that we have for this session. I will, of course, give an introduction to nearly zero energy buildings. I will talk about the reporting template, which is meant to be used by the member states in order to report on their progress in the implementation of nearly zero energy buildings. As we will see, especially when it's about the concrete definition of nearly zero energy buildings, there are some specific issues which may affect the key performance indicator for these buildings. Then we dealt about benchmarks for nearly zero energy buildings for different European climates, because you can imagine when the climate differs that this also might affect the key performance indicators such buildings may have. We also had a look at the convergence between cost optimality and nearly zero energy buildings, because in principle these are different concepts, but on the other hand, as Fernando already pointed out, every new building from the 1st of January 2021 should be nearly zero energy standard. And so the question is, will this be matching the additional requirement of cost optimality? And finally, as we did so many stuff in this project, and at that point I will have told you quite a lot of things, it's time to go to the conclusions and recommendations. So why are we dealing with that? So probably most of you are aware of the overarching target of reducing the emissions. I gave you a picture here of the emissions gap report for the climate conference in Cancun, which gives several scenarios that give the world a chance to stay below the 2 degrees Celsius target. All the scenarios having, sufficient probability, as you can see the above chart, a likely chance or a medium chance to arrive at that 2 degrees Celsius target, say that the world's greenhouse gas emissions should peak before 2020, and compared to 1990 levels by 2050, the world greenhouse gas emissions should have been reduced by 50 to 60%. As in Europe, we are in an industrialized region of the world, and we have by far more greenhouse gas emissions per capita than the most rest of the world. This means that Europe has set a non-binding target themselves to achieve minimum 80% greenhouse gas reductions compared to 1990 and 2050, but depending also on what the other nations in the world do, up to 95%. So when we break this target down, so to different sectors, what does it mean for different sectors like the power sector or the building sector relative to greenhouse gas reductions? Here you can see what would happen for the power sector and for the building sector when we assume the 80% reductions target for the European Commission. It means that until 2030, this is the green column, the power sector should reduce their emissions by 54%, whereas the building sector also should have a significant reduction by 37%. By 2015, obviously these numbers increase significantly, power sector minus 93%, and also very significant decrease to be achieved by the building sector, which is 88%. So as I said, that was for the overall European reduction target of 80%, but when we have a look at the maximum target of 95%, obviously all the sectors also have to have higher reduction targets. As you can see here, when we assume the 95% reduction target for Europe, this means minus 99% for the power sector and minus 91% for the building sector. So, yeah, in principle, this is a very impressive target, and de facto it means that, yeah, not only some landmark buildings will make the target, but in principle we need more or less 100% landmark buildings or pilot buildings, so the kind of pilot buildings that we see today by 2050 in order to achieve this target. And the standard that matches these minus 91% is the nearly zero energy building standard. That's the idea of the European Commission. So let's have a closer look at nearly zero energy buildings. As I pointed out at the start, the expression or the name nearly zero energy buildings is to be found in the updated Energy Performance of Buildings Directive, which is also referred to as the EPBD. And in Article 9 it says a nearly zero energy building is a building that has a very high energy performance. The nearly zero or very low amount of energy required should to a very significant extent be covered by energy from renewable sources, including renewable energy produced on-site or nearby. So I highlighted some of the expressions, and during the next half an hour we will get back to these highlighted areas again. So what you can see in the time line at the bottom of the building is that, well, today we are somewhere in the middle between the building stock and the nearly zero energy requirement, which you see on the left side. So I highlighted the zero, and the building very close to it should be the nearly zero energy building. And the sun symbolizes that we won't achieve the level of nearly zero energy buildings without supplying it from renewable sources. There are several questions about nearly zero energy buildings. Obviously, it's quite a new term, and obviously, as all of the 27 EU member states had to agree to this expression and to the definition in the European Performance of Buildings Directive, it naturally is a bit fuzzy. So the definition that I just read out, yeah, is a bit fuzzy, and many of the expressions that we find there leave quite some room for interpretation. And one of the major tasks of this project I'm talking about was to interpret these expressions in order to give a bit more guidance for the Commission, but also for the Member States on how to interpret this quite fuzzy definition for nearly zero energy buildings. So the most burning questions around the definition I just read out is, so which options do we have to achieve nearly zero energy buildings? How exactly do they look like? What building elements do we need? Are they already available, or do we have to develop something in order to achieve that? What about the share of renewables? It said something about a significant share. So what is significant? And again, what is nearly zero? What is nearly? Is it 100? Is it 10? Is it 1? Is it 0.1? So things to be found out. And the final burning question is, as we have the other ruling principle in the European Performance of Buildings Directive of cost optimality, do nearly zero energy buildings not only have to fulfill the requirements that we just saw in the definition, but do they also have to be cost optimal? In order to be clear about what we are talking here, I would like to give some pillars around nearly zero energy buildings. So first of all, you should be aware that we are talking about residential and non-residential buildings. So the term is valid for all kinds of new buildings. So by 2021, all new buildings are to be nearly zero energy buildings. Then the question is, what, according to the European Performance of Buildings Directive, should be included in the balance, which should be nearly zero? And the answer is at least heating, domestic hot water, cooling, ventilation, lighting, in the case of commercial buildings, not in the case of residential buildings, and auxiliary energy should be included in the balance. What is not included, but it would be up to the member states to also include it in the balance, are plug loads like electric appliances, things like elevators, or whatever you can think of uses electricity in a building. An overarching principle that we find in different documents that have been published by the European Commission is that first energy needs should be reduced, and then after having reduced the energy needs to cost optimal level, the rest, which is close to zero, should be covered by renewable sources. When we look at it from a different angle, because at the start I pointed out, in the end, we are talking about nearly zero energy buildings as a means to achieve the European climate targets. The question is, what does it mean relative to climate targets? So in a parallel project, we made a calculation within Ecofys how many tons of CO2 the European building stock would be allowed by 2050 to emit in order to be in line with the very ambitious reduction targets for greenhouse gases that I just told you about. And the surprising result is that considering that today we have like 30 kilogram CO2 per square meter and year emissions in the building stock, so the square meters is the floor area, the total floor area of the European building stock, so all existing buildings and all upcoming new buildings that we expect by 2050, only 3 kilograms of CO2 would be allowed to be emitted on average in the building stock. So now you can imagine that in the buildings that we have today, it will be harder to get close to zero than for buildings that we construct in the next 35 years. And it also means that the buildings that we have today probably will be or will have more emissions than 3 kilograms CO2 per square meter, but on average, the 2050 building stock should be 3 kilos. So it means that all the buildings that we construct from today until 2050 literally should be very close to zero in order to make the average European building stock having 3 kilograms CO2 emissions by 2050. So a nearly zero energy building also means a nearly zero emission building when we are serious about the European climate targets. So the definition that I just showed you, it's quite vague, and it means that at the moment there is no more specific definition available in Europe. And so we try to get a bit closer to that. The European Performance of Buildings Directive asks the member states to set up national plans on how they intend to achieve the nearly zero energy standard for new buildings by 2050. This request of the Commission is on the one hand meant to push the member states to really actively develop a strategy on how to reach nearly zero energy buildings by 2050. But it's also meant to give them a monitoring tool on what they do and also to help the commissions, to help the European Commission, to give an instrument that again helps the Commission to help the member states, because the European Commission, all the people that we are dealing with within the Commission, they are not really acting like controllers, and they don't want to urge the member states to achieve something which doesn't make sense, but they really would like to help the member states to make this requirement happen very smoothly and with a long-term strategy. And therefore, they are very interested to give very structured templates to the member states where they can think about the measures which will be needed to achieve nearly zero energy buildings by 2050. The European Performance of Buildings Directive has very specific requirements on what should be the content of these national plans for nearly zero energy buildings. They shall include, amongst others, the application in practice of the national definition of nearly zero energy buildings. I just showed you the quite fuzzy general definition in the EPBD, but obviously every member state needs a much more specific definition that it can work with. Another requirement is that the national plan should include intermediate targets. So, for example, what percentage of new buildings by 2015 should already have the standard of nearly zero energy building. Then you can imagine that all kinds of policies and financial or other measures will be needed in order to promote the development towards nearly zero energy buildings, and so the member states are also asked to provide this kind of information in their national plans on how to increase the number of nearly zero energy buildings. When these plans have been handed in to the Commission shall evaluate the national plans, notably the adequacy of the measures envisaged by the member states. If the Commission thinks that information is missing that would help them to judge the progress in the member states and also to think about how they could support the member states to achieve the required number of nearly zero energy buildings, they also may request further specific information. So that means in order to help the member states and also in order to help the European Commission to evaluate these national plans, a common reporting format obviously is very helpful. So such reporting format, for example, is also available for the national energy efficiency action plans or for the national renewable energy action plans. And experience shows that as soon as such template is available, the Commission cannot force the member states to use the templates, but they can ask them to use them. But as soon as such templates are available, usually member states are happy to have them and they usually also use them. About the plans, of course, there are also dates when they have to be handed in. And the due date for the first plan for how to increase the number of nearly zero energy buildings in a member state had to be handed in to the European Commission by the end of 2012. So the year of 2013 was already a year where some of the member states had handed in plans, not all of them, and the Commission was able to already have a first look at what member states' plans are on how to achieve this requirement. So as I said, the template for national plans is on the one hand a reporting template that is to be used by the member states, or not, it's not is to be used, but it may be used by the member states, so they are encouraged to use it. And it also serves the Commission as an analytical framework in order to judge the progress in the member states towards nearly zero energy buildings. So categories that are reported are, for example, the starting point. So here, for example, the member state can give a short overview of the national building stock, a description of the most important characteristics, a chronological development of national requirements on the energy performance, and so on and so forth, in order to set the scene for the following information. One of the core parts is the application of the definition of nearly zero energy buildings. I will get back to that in the next slide. The intermediate targets are already mentioned, and it is also important, there are not only intermediate targets for residential and non-residential buildings, but there is a specific target for new buildings occupied and owned by public authorities, as they have to fulfill the requirements that every new building has to be nearly zero energy building already 2 years earlier than the rest of the buildings. That means from 1st January 2019 on, all new public buildings are to be nearly zero energy standard. The same goes for the policies and measures, explicitly also what intends a member state in order to make their own public buildings nearly zero energy buildings. Okay, of course they can give additional information, and what I think is also a very important section in this reporting template, which is provided to the member states, is a self-assessment category where they can say where they see possible improvements in their plans and strategies on how to achieve the nearly zero energy building standard. So one of the core questions is, how do member states in fact define the nearly zero energy building standard? Do they fulfill the requirements of the EPBD and also of the Renewable Energies Directive? And this is in principle a very technical question, and specifically for this technical question, another Excel template was developed which helps the member states to define especially the boundary conditions for calculating the benchmark they have in their in their country. I will get back to several issues around it, but here you see the start of this template, and here it's pre-filled by Denmark. Denmark was so nice to help us in testing the template. So you can see the member state can tell the Commission which building categories are included in the actions around nearly zero energy buildings. Does it only include new buildings? Does it also include retrofitted buildings? And in principle, all the rest of this Excel template is about how exactly the energy balance for nearly zero energy building is calculated. Because as you can imagine, there are several ways to calculate an energy balance, and when the Commission would like to assess the progress in a member state, it's very important for them to exactly see what was included in the balance, what was excluded in the balance, in order to make different numbers that come from different countries comparable. So you can easily imagine that, let's just assume one country sets a limit that a nearly zero energy building may have maximum 50 kilowatt hours per square meter in year primary energy consumption, might be a less ambitious target than another country which has 80 kilowatt hours per square meter in year, but includes much more things within the boundary for calculating the balance than the other country. So it's very important to have absolute clarity about the boundary conditions that are used for calculating the energy balance of a nearly zero energy building. And it also specifies very good, when you apply this template, what exactly you mean with the term nearly zero energy building in your country. So we have specific issues that are addressed in this Excel template that I just told you. And one of the issues is that, yeah, as the definition already says, we have different boundary conditions. I already read it out. It says including energy from renewable sources produced on-site or nearby. So some countries interpret this that only renewables produced on-site or nearby might be included in the balance, but I think the correct interpretation is that this is just an emphasis, but in principle all kinds of renewable sources may be included in the energy balance, so also off-site energy. So we have these different expressions, on-site energy, nearby, and off-site. And yeah, one of the questions which is fervently discussed currently is, should off-site renewables be allowed in the energy balance of a nearly zero energy building or not? we think it should be allowed. Sorry, I will jump back. Yeah, and why do we think it should be allowed? Because buildings have very different boundary conditions. Just imagine you have a freestanding building, no buildings around, no trees around, so you will have maximum solar gains, but compare it with another building which is in the middle of a city with a lot of shading, and these are very different conditions, and it also would create very different efforts for the two building owners of building A and building B to achieve a nearly zero energy building. And therefore, we said, yeah, when you open up this area here to, let's use the arrow, to also include off-site renewables, you have much more choices to achieve the nearly zero energy building standard. And that means in the end that different building owners with different boundary conditions will have more options, and this gives more fair chances to achieve the nearly zero energy building standard. So off-site renewables definitely also should be included, and it's also covered by the definition in the EPBD. So as soon as you have a single building, which is on your building plot, obviously, and you also include a second boundary condition, which is nearby or off-site, you have different areas, and then you have imports and exports of energy between these different areas. So just imagine you have PV on the roof, then there will be times where you export energy to the surrounding area, and there will, of course, be times where you import energy. And this obviously is quite decisive for the energy balance that follows for your nearly zero energy building. So one of the things which is discussed is the metric and the period of the balance. So this affects the balance of a nearly zero energy building and the key performance indicator, the primary energy value that you set, a lot. So the EPBD only requires national zero energy buildings definitions to include a numerical indicator for the energy performance, but which metric to use. So one thing is clear, the EPBD requires that you state a primary energy value. And usually this is done by calculating the delivered energy and then multiplying it by primary energy factors, which not always are very transparent, but also bound to political decisions. And we also have to see that, for example, for electricity, a steep decrease in the primary energy factors of electricity is foreseen, and that also affects the energy balance of a nearly zero energy building. The period of the balance, what is usually done is we are doing a net balance over 1 year. So we say, okay, what is consumed by the building for heating and cooling and ventilation and hot water? And on the other hand, we say, okay, what is produced, for example, let's make it easy, by a PV system on the roof during that 1 year. And the moment you have a zero balance, so my PV systems produces as much as all the other systems use over the year, you could call it a zero energy balance. But the question is, that is a logic that applies for a 1 year interval. But let's just take the example I did. So we take a 1 year balance where just the production from your PV system matches the annual consumption of your building. But when you switch to shorter subintervals, you will see that jumping to monthly, daily, or hourly balances, there are quite few hours in the year in the same building, which just had a zero balance from an annual point of view. There are quite few hours in the year where your on-site production really matches the energy need that you have in that hour. So it means In fact, in this case, and this is quite usual what we see here, your net zero energy balance or your zero energy building can only live without importing energy, although you have a large PV system on the roof, for example, for 25% of a year's hours. And this puts quite some stress on the electricity grid. And so one of the discussed questions we currently have, and that we also discussed in the project, is, so what should be the length of the subinterval for balancing imported and exported energy? And currently also seeing the restrictions of calculation programs, the Solomonic average seems to be that, okay, let's stick to monthly balances, and maybe in the future when we have more advanced and even easier to use software, we can switch to hourly balances in order to give a more realistic picture of not only the energy balance, but also the stress the building causes when we are talking about a nearly zero energy building that makes his balance zero by using electric renewable energy. Of course, you can't only use PV on the roof in order to achieve a nearly zero energy balance, but the European Performance of Buildings Directive, of course, allows all kinds of renewable energy to offset your energy consumption, like biomass or also biogas. So all kinds of renewables, water energy that you could think of. Yeah, during the project we also had a look at the different definitions we found, so not just from the plans for nearly zero energy buildings, which were not even available at that time, but more unofficial definitions. We found 71 definitions that you could call are meant to be nearly zero energy definitions from 17 EU member states and 2 countries beyond the EU. And here we had a look at, is it allowed to include renewable energy which is only on the building's footprint? Is it allowed to include on-site, so on your buildings, on the piece of land where your building is? Is it allowed to include energy which is produced there? Would it be allowed to use a green electricity, so off-site generation? Or would it also be allowed to just buy green electricity? And as you can see, there is a strong focus, so most of the definitions allowed renewable energy being produced on the footprint, which clearly means something like solar thermal panels or PV on the roof. A lot of definitions also allow, so this is the yes, the dark green is the yes. A lot of definitions, in this case 55 definitions, also allow on-site renewable energy. Only 18 definitions allow to include off-site generation of renewable energy in the balance. And last but not least, 9 definitions allowed to also include green electricity. So there is a big bandwidth of options that are given in the member states, but you can see that most of the member states currently interpret it like, okay, the green electricity or the renewable energy should be used or produced on-site or on the footprint of the building. So the benchmarks. For calculating the benchmarks, we applied the cost optimality logic. I will explain what we did in the following charts. So we explicitly applied the cost optimality logic, which is also a core part of the recast European Performance of Buildings Directive. In principle, you have to calculate 2 things. On the one hand, you have to do a global cost calculation for a building. In the case of residential buildings, for a period of 30 years, and for non-residential building of 20 years. It's a net present value calculation, and you have to include in the net present value calculation for a certain building, which is meant to be nearly zero energy in our project, and according to the cost optimality methodology, the initial investment. You also have to include the annual costs for every year, the running costs. This obviously also includes the energy cost. If you know how much it is, you can include the final residual value and the disposal costs. Two different perspectives have to be taken. You have to do this calculation from a macroeconomic perspective. This means you have to exclude taxes and subsidies, which, for example, reduces electricity prices. You can include, no, you even have to include carbon costs, and you have to do the calculation with a macroeconomic discount rate, which is usually much lower than the rate that has to be used in the financial perspective, which is the second one that has to be calculated. And this is, so to say, the perspective from a private building owner, whereas this is the society's perspective. So on the x-axis, you have the primary energy calculated per square meter in year for your building. Here, the y-axis is the global cost. And now what you are doing is you take different variations for building components, for example, different quality level for your building shell, for your building envelope, for the windows. You can combine it with different levels of heating systems, cooling systems, shading systems, and then you get all kinds of variations that will lead you to a certain value, for example, for the combination number 6, to a certain value for the primary energy consumption, and to a certain global cost. And usually what you can imagine is that the higher your investment is, the lower is the net present value of your energy cost during the lifetime. So you add both up, and here in the case of 6, you have a very poor building which has low investment cost probably and very high energy cost. Then you invest some more money, and you overcompensate this additional investment by the additional energy savings, which reduces your total cost. This goes on until 4, and finally you reach a point where your additional euro of investment in the quality of the building and in the energy efficiency of the building also reduces your energy cost by 1 euro. So then you have the minimum, and every additional euro that you invest will lead to energy savings during the lifetime or the calculation period, which are less than 1 euro. This means the total cost rise again. And now the requirement of the Commission is that every country has to do this cost optimality calculations for all kinds of buildings, and then you will see this economic optimum. So which primary energy level is at the economic optimum, and the minimum energy performance requirement a member state defines should be at least this economic optimum. This is the logic behind the cost optimality. So the current assumption is that, and that's also the idea of the Commission, currently we are here, probably in many of the member states' building codes. This is the requirement, and probably in many countries there is some room for improvement at even lower global cost. So this is the current requirement, and then you see there is also a combination that has lower global costs and a lower primary energy consumption. And the expectation is that at the moment nearly zero energy buildings are somewhere here, close to zero, but most probably the global costs are higher than what we see today in the cost optimum. So we did these variations, so I just showed you an example with 6 points. In fact, we did very complex combinations in the project, so we generated thousands of variations, and then you get a lower limit of this cloud of variations that gives you for every primary energy consumption level a combination with the lowest cost. And this is, so to say, the cost optimal curve for every energy standard. So then we try to analyze the area close to zero energy. We did it like that. We defined a so-called benchmark area, and it went like this, that we said, okay, we have a look at the variant with minimum net primary energy. Then we consider an increase of 15 to 25 kilowatt hours. Then we say, okay, it is allowed to increase the global cost by 15 to 25%. And so we got this area, and you can imagine we had several thousand points, that still several hundred points were in this area that we analyzed more closely. And the results were relative to the requirements of net primary energy ranges that in all cases the single family homes, this is SH, had lower primary energy values than the office buildings. You can see these are the single family homes. These are the office buildings. And you also can see that going from south to north of Europe, these values get higher. So, and you also can see the range where they are. So, yeah, some are really close to zero already. This is the net primary axis. And the highest values that we calculated was around 60 for an office building in Stockholm. Then we closer analyzed the requirement for the building should have a very high energy performance. This means it should have very low energy needs. And here let's just have a look in order to explain this graph at Catania, the office building and the single family home, and Stockholm, the office building and the single family home. So when we look at the office building, the energy demand for heating, imagine this is the percentage. I just showed you the benchmark area. So we had several hundred points in the benchmark area, and this graph says that approximately 65% of all the buildings in the benchmark area in the Catania office building had an energy demand lower than 15 kilowatt hours per square meter in year for heating. For cooling, you can see this is the light green. Approximately close to 70% of the office buildings in Catania had an energy demand between 10 and 20 kilowatt hours per square meter in year. When you compare it to the office building in Stockholm, you see that the classes with higher energy demand have a much higher share, which can be in principle easily explained. Office buildings have higher glazed areas, and so they have higher energy losses. And so you have, and lower irradiation, solar irradiation. So obviously you have a lot more buildings with a higher energy demand in this area in Stockholm than you have in Catania. So what about the share of renewables? This is the same order of buildings that we've just seen and the same order of the places in Europe. And you can see the share of renewables that we calculated for the buildings we've just seen. So usually, of course, it decreases again from Southern Europe to Northern Europe, which means that the buildings in Catania and Southern Europe, they could easily achieve renewable shares between 70 and 90%, whereas the buildings in the north of Europe, in Stockholm, were more between 30 and 40% of renewable energy. So that means that, in fact, there's probably some reason to make a difference in the benchmarks and the requirements, for example, for the share of renewables, depending on where in Europe you are. So then we had a look at the global costs and their relation to the energy classes. So here you see energy classes, which are the sum of heating and cooling. You see, again, how many percent of the buildings fall in which category. For example, here you see almost 20% fall into the category of 30 to 45 kilowatt hours per square meter in year energy need for heating and cooling. And here you see the global cost. This is the average value, and this is the standard deviation. And what you can see here is that there are still combinations of building components which have the same average cost than the other categories, although the energy demand in these categories is much lower than for these categories. So it clearly means it is possible to have nearly zero energy buildings that at the same time have a very high energy performance, so a very low energy demand. But yeah, there are very few combinations that match this requirement, and so it means you really need experts, architects, who really know which elements to combine in order to achieve this level at reasonable cost. So the summary of the results to energy needs, we had the different climate zones, and to make it short, for most of the zones it turned out that the cost optimal level for the calculations with 2010 costs in many cases was already quite close to a passive house level, which would be below 15 kilowatt hours per square meter and year. But generally, all the values for the energy needs lay between 15 and 13 and 30 kilowatt hours per square meter and year. So if you know how to do it, you really can achieve very cost-efficient combinations which have very low energy needs. So then the question is, do we see a convergence between cost optimality and nearly zero energy buildings? This is the Commission's view, and we had a questions and answers round with the Commission, and there was one participant who asked this question. After 2013, all new buildings and renovations shall be based on cost optimal requirements. That's clear, that's the requirement of the EPBD that I just explained. But now, how is it with cost optimality of nearly zero energy buildings after 2020? Do they also have to be cost optimal? So this is the reply of the Commission. Basically, cost optimality and nearly zero energy buildings are two different concepts, but nevertheless, the minimum energy performance requirements for new buildings after 2020 will have to be cost optimal as well. So, you know the rule of the Energy Performance of Buildings Directive. The minimum standard that you require in your country has to be cost optimal. So that, on the other hand, means, so if by 2020 the requirement should be nearly zero energy buildings, this also should be cost optimal. And what did we see when we analyzed the difference between 2010 and 2020? So the calculations I just showed you were done for 2010, and then we made the same calculations for 2020. For the 2020 calculations, we made assumptions on how energy prices would develop, but especially how component prices, which are critical for achieving the nearly zero energy buildings level, would develop. We made very cautious assumptions for these components, and in fact, the general result was that happened what you see here when this is the 2010 situation. On the left side, you see cost optimal is a bit far away from nearly zero energy building, but what you would hope is that by 2020, the cost optimal region that you see on the right side is very close to nearly zero energy level, or even matches exactly the nearly zero energy level. Here you see different curves that we produced for 2010 and for 2020. You see the straight line, the light blue line is the 2010, so it's the, sorry, I can't use anymore the arrow. I don't know why. Maybe I'll try again. Yeah, well, this is the 2010 level. And when you click here, you see that when we calculate the same curve for 2020 level, this is the dotted curve on top of the straight curve. The minimum has moved from approximately 160 to 100. So there is really a clear move of the cost optimum towards zero. Well, and this brings me to the conclusions and recommendations of the project. Nearly zero energy buildings usually are correlated with very low energy needs. So we found that in case you use combinations that have relatively high energy needs, it's really hard to achieve a level that could be considered to be close or equal to zero. And most of these buildings, in fact, were quite close to what today we also know as passive houses. Buildings constructed with very low energy needs have global costs over 30 years, lower or comparable to buildings with high energy needs. I think that's also a very important insight, that really the low energy consumption compensates for the higher investment cost when you find the right combination to achieve it. The results seem to be relatively robust towards changes in various economic parameters. You've seen that we did very complex calculations, but the general finding that I just told you didn't really change when changing, for example, interest rates within reasonable limits at least. The economic attractiveness of low-energy buildings grows when we consider the scenario of constructing a building in 2020. So in fact, by 2020, it will be more attractive to construct a nearly zero-energy building than today. In all of the cases that we calculated, so all climates, office buildings, single-family homes, the cost optimum moved towards zero. So the gap that we see today between cost optimal level and nearly zero energy level will definitely get smaller in the next years. Yeah, this result is reinforced in case energy prices would rise more significantly than assumed. As I told you, we were quite cautious in the assumptions we made. This is the final slide. Conclusions and recommendations. You see, we were also very modest in the way we formulated our conclusions and recommendations. It is likely to be a good economic investment to continue support for innovation and to completely close the gap between cost optimal and zero energy. So we've analyzed, for example, several building performance developments in several countries for the last years, and when you just extrapolate these curves, how the energy performance requirements were increased during the last years, in fact, in many cases, you already end up at a value close to zero when you assume, okay, the next few years will see the same progress than what we've seen in the past. Not to forget, and this is usually a bit, it's a pity that this is forgotten in the pure economic assumptions. Buildings with low energy needs definitely have supplementary benefits, which also could be given a value, but this is usually not done, like higher thermal and visual comfort. The project clearly showed that nearly zero energy buildings, in fact, are the building's cornerstone for the EU 2050 climate targets. Currently, on-site renewable energy is in the focus when discussing about nearly zero energy buildings, but we found that in order to get these buildings implemented on a large scale, just focusing on on-site renewable energies won't be enough. Definitely the handling and inclusion of off-site renewables should be dealt with in the balance of nearly zero energy buildings. And last but not least, it also turned out that only very high demand reduction and a very significant share of renewable energy will succeed in achieving renewable energy. So it's not realistic to only rely on renewable energy or to only rely on demand reduction. Thank you very much. And now I'm looking forward to your questions.
Okay, thank you very much, Andreas, for these very comprehensive views on the topic. We have had a lot of attention to this presentation, and a number of questions have already been submitted. So let's maybe go through them. There are some questions of clarification, and there are other which are rather comments or further reflections. So let's probably start with those technical clarifications. So we have a first question, which is whether a refurbished building can be considered a new building. You presented a slide relative to what is applicable to new and existing buildings, but maybe a short summary of what is expected for major renovations and so on. So
yes,
thank you.
Yeah. Mm-hmm. So that's a very good question, of course, because the major problem is the building stock, obviously. But still, the term nearly zero energy building is binding for new buildings, but explicitly member states are encouraged to also set up plans on how to increase the number of nearly zero energy buildings in the case of major renovations. So that's the current content of the EPBD. So there is no general requirement to achieve nearly zero energy buildings in the building stock.
Okay, good. Another question of context, are industrial buildings included in the requirements?
Yes, so as far as they belong to, so according to your national building standard, when they belong in the framework of your national building standard, they are included, yes. So, but generally, residential and non-residential buildings are included. So, yeah, this kind of buildings would be included in the non-residential buildings. So, yes, they would be included.
Okay, good. So, we have another question. The EPBD is referred to new buildings. What is the expectation of new buildings in Europe? Is it congruent with the real needs of new buildings on the market? The average age of European people is very high, and till 2050, a lot of old buildings will be available on the market. The EPBD take care about it. So I think you already mentioned a little bit this topic. Have you any additional views?
Yeah. So it's in fact has some overlap with the previous question, but still, I mean, we are talking about quite a long time still, from 2014 to 2015. This is like 36 years from now, and the expectation is that 25% of the building stock that we will see in 2050 will be built between today and 2050. So in fact, we are talking about quite a relevant share of the building stock in 2050, even if we only address the new buildings at the moment. And yeah, as you can see, the EPBD already mentions major renovations. So I think one of the upcoming updates of the EPBD probably will also make mandatory requirements on major renovations, although today it's just a recommendation to also include them.
Okay, good. So relative to the renovation rates, I'm just writing in the speaker's contact and references a link for an upcoming webinar on the expected rates of renovation on some scenarios that have been drafted by Ecofys. So here you are the link. If this is a topic of your interest, you're definitely invited to register for this webinar. Okay, good. We have another question. Renewable energy sources are almost compulsory to have a near zero energy building. So what will happen if the national legislation doesn't allow self-consumption or applies a tax to the self-consumption, which is today the case in Spain?
In fact, I have to think about this. So I mean, that's the advantage of having national applications of the definition of nearly zero energy buildings in the country. So if this, I mean, of course, every country has very different specific boundary conditions, and if this is a requirement in Spain that it shouldn't be allowed to take this into consideration, then obviously the benchmark value for primary energy consumption should be adapted to this situation. But at least as to the requirement on the energy demand, the energy performance of the building envelope, it wouldn't make a difference. And yeah, this is first of all the conditio sine qua non the nearly zero energy buildings can be made. That first of all, you have a very good building shell that matches the local climate conditions.
So there is some, let's say, regulation harmonization to be done in order to accommodate the near zero energy
Yes, so I
building
mean there is
requirements.
no, to the extent the national legislation allows it, you have to implement the quite vague definition of the EPBD. So, but then, yeah, of course, as I said, every member state has to see how the national specific conditions fit to this definition that I just cited from the EPBD. So, in principle, yeah, it's not a problem if this is the case in Spain.
I see, thank you. So there are some questions relative to off-site concept. So one is how far is off-site, and whether electricity transmission and distribution losses are to be accounted for greenhouse gas emission targets, or well, the accounting for the building.
Mm-hmm. Yeah, that's also a good question, which we analyzed in another project quite in depth. When you take the definition of the EPBD, it says on-site and nearby, and you already can start by asking the question, okay, what is nearby? Is it 10 meters, 10 kilometers, 10,000 kilometers? There, for example, was a legislation in Denmark where they started to only take into account wind energy in the balance of municipalities, for example, when it was on the plot of the municipality. So in the meantime, these wind plants are still called nearby, but they may be distributed all over Europe. So, and it's quite the same with off-site. I think in principle it can be everything in your country or even beyond your country, imported electricity. So I don't think there is a limit, but in fact, as an interesting information, currently the so-called umbrella document, the Euronorm 15615, which is really dealing with how to set up the balances of buildings, is under discussion because, as your question shows, it has to be updated, having the background of the net zero energy buildings definition. And in fact, the experts have a lot of discussions about this topic, and it's not finally discussed yet where the boundary of on-site and off-site and nearby should be. So, but I think for the reasons I pointed out, the boundary for off-site will be quite far away. So at least the boundary of their own country.
Okay, good, thank you. Another question which is related to the already mentioned self-consumption concept. So the legislation in this country, so in the country of this person, it seems like in Serbia, do not allow a sale and exporting of new energy production by private or legal entities to the system. So I think the question has already been addressed, unless you find additional comments, Andreas.
Yeah. Okay. I mean, maybe this question also reflects that usually in the context of nearly zero energy buildings, we are very much thinking about electricity. But as I pointed out, there are also a lot of other ways to achieve the nearly zero energy building standard. For example, if you have a biomass boiler, then it shouldn't be too hard to achieve it. Or if you have a biogas connection, for example, biogas in your gas grid or whatever. So that's, of course, also a possibility. So in principle, this is really a specific question for electricity, and there is also quite some difference in the countries if, well, you get paid if you get a feed-in tariff, or if you just don't get anything. Yeah, and then there is also the case which is mentioned here that you aren't allowed to export anything, which in fact would mean that you have to switch off or to decouple from the grid the moment you produce more than you need. So that would be quite a complex way of controlling a system then. But yeah, I think one of the major answers is that it's not only about electricity, how you can achieve nearly zero energy buildings.
Okay, thank you. We have another question. In small district heating, the name in German is indicated, I'm sorry.
Mm-hmm.
On-sites or off-sites, and would generally accepted in near zero energy building?
Yeah. This is something which is under discussion currently in the umbrella document. But as far as I can see, the discussion will end in that, yes, this will be acceptable to be included as on-site or off-site. Sorry, as nearby. This would be a typical kind of nearby renewable energy, what we see here in the question.
Okay, good, thank you. We would have some comments on how the minimum life cycle cost is calculated.
Mm-hmm.
So we would have discount rates, but also I would add the time horizon for life cycle calculation for economic purposes. The lifespan of a building can be 50, 100 years.
Yes.
But of course, we are not considering investment decisions based on operation costs over 100 years, maybe 10, 15 years, but no more.
Yes.
So, any comment on this?
Yes. The cost optimality methodology prescribes, so you have to do a calculation for a residential building with a calculation period of 30 years, and you have to do the calculation for non-residential building for a calculation period of 20 years. And you are right, usually the lifetime of buildings is longer, and therefore the methodology says that you have to subtract residual values, so the part of the investment which still has a value beyond these 20 or 30 years has to be subtracted from the original investment cost. So this is taken into consideration. So, but the maximum observation period or calculation period according to the cost optimality guideline is 30 years for residential buildings.
Okay, so there is a clear number of years for calculation.
Okay. So the member states are not free to choose.
Okay, excellent. Okay, another question, do you think that emerging energy harvesting and energy storage technologies could play an important role in achieving the near zero buildings objectives?
Yeah, as I pointed out, it very much depends on how you calculate the balance. I mean, if you really say, okay, we have a very short, that would so the storage wouldn't make any difference when we, for example, take the annual balance. So then you just generate, for example, 1,000 kilowatt hours, and you may take this into consideration in your balance. But without a battery, you probably only might actually directly need 250 kilowatt hours in your building. So if you would have a battery, you probably might be able to use 500 kilowatt hours from these 1,000 kilowatt hours. And then it would depend what allows the calculation, the national calculation principle for your nearly zero energy building. Does it allow you to take into consideration the 1,000 or the 250 or the 500? But this is really a national decision in the end on where to set the boundaries. That's why I also emphasize this point so much, that without exactly knowing these boundary conditions, you are really not able to compare different numbers from different countries. But yeah, depending on the national definition, a battery might play a very important role.
Mm-hmm. Okay, thank you. How do you choose the combinations of the measures in each calculation? Did you use any statistical model like Monte Carlo? I'm not sure whether to which particular page of your presentation this question refers.
I think I know what this meant. So we had this picture where I showed the cloud of options, and I said we
do you want to show it again?
Yes, yeah, I can jump back. Let's
so please.
We'll find it.
Oh, sorry.
Don't worry. I meant this picture. Switch this off again. Okay. Yeah, what we actually did was a stochastical approach where, yeah, as I said, I will make an example. For this building in Paris, single house, new building, for example, we had 3 different U values for the walls, 3 different U values for the roof, different U values and G values for windows. Then we had different amount of PV area, different heating systems. And then, in fact, we had costs for all these options. And then we combined everything with everything, more or less. And that's the cloud that resulted here. So you can imagine when we when we give different options to all these building elements, you explosively end up with several thousand options. And all of these were calculated in a batch process using a dynamic thermal simulation. So these calculations even were done with 8,760 hours with Energy Plus. And yeah, then each of the results was put in this graph here.
Okay, good. So we will go back to the Q&A pod, and we will go to the next question. There is a lot of questions, so I believe we will not be able to go through all of them. So I suggest we will treat the pending questions, as there are still many, and unfortunately we will not have time to go through all of them. We will make a written summary of the questions, and will be published in the same web page where recording and presentation will be available.
Yeah, okay, so if it's okay with you, Fernando, I would have 15 more minutes to reply to these questions, because I think it's very relevant, and I'm really happy to answer to these questions.
Okay, no problem. So let's then stay for a few more minutes, and let's try to address orally. Okay, so another question. I heard considering to compare climate conditions, climate severity index is proposed, a sophisticated version of the degree days, taking into account the summer as well as the winter severity of a location. See as EPBD, comparison of energy performance requirements level, possibilities and impossibilities summary report. Any comment?
Yes, we had a very long discussion before we selected the climate regions that were taken for the dynamic thermal simulation. And the SEPI approach, for example, was also taken into consideration in that. So at this point, I really would suggest that you have a look into the full report, which is available on the Ecofys page, and also, of course, on the page of the European Commission. But yeah, it was also taken into consideration in the analysis that we performed for the selection of the places for which in the end we did the calculations.
Okay, good, thank you. Another question, do we have to use a monthly or an hourly step for our calculations?
There is no prescriptions in the EPBD, so if the standard in your country is to do the calculations on a monthly basis, you are free to do so. And in fact, I think that's the reality in most of the countries, that monthly calculations are performed. So in very rare cases, hourly steps are common. I think probably in none of the countries. In fact, in Europe, we just did it in order to get deeper insights in this project on an hour-by-hour basis, also with regard to the share of renewable energy. But of course, in your country, you would be free to use a monthly basis.
Okay, thank you. So there is another comment on cost optimality. When it leads to very high investment, even if on life cycle basis, it's the best solution. We could be facing a very expensive building to adopt. So there is an underlying notion of access to finance and how to, well, to make upfront cost payments for future savings, whether this will be feasible or whether everybody could deal with this. Any consideration, any comment up to here?
Yes, I mean the question is very valid, so it really depends on what is considered to be cost effective. So I fully agree. Most people mainly look at the initial investment cost, and yes, of course, as I explained for the cost optimality curve, usually lower energy consumption will be related with higher initial investment cost. And then, yeah, it's really up to the market and also to the banks to what extent they will follow this approach of cost optimality, where on the other hand, of course, if we talk about loans, there is a much smaller risk that somebody can't pay back his loan when the energy cost is close to zero. But yeah, at the moment at least, that's also something which would be a part of the national plans for increasing the number of nearly zero energy building, that financing mechanisms are developed which match this concept of cost optimality that by 2020 also should be in line with the nearly zero energy building standard. Hello?
Yes, sorry. I'm not sure we addressed previously the question relative to the discount rate to be used in the calculations.
Yeah, sorry, I think we didn't really do it. It's found in the cost optimality guidelines, and in principle every member state is asked to use at least 2 discount rates for both perspectives, so for the socio-economic perspective and for the private perspective. And for each of these perspectives, the guidelines prescribe one value, and the other calculations, the member state is free to choose another rate. As far as I remember, for the private perspective, one calculation has to be done with a discount rate of 4%, and for the macroeconomic perspective, one calculation has to be done with 3%.
Okay. Okay, thank you. There is another question relative to the impact of geothermal heat pump systems in near zero energy buildings. Any existing assessment or any preconization relative to this?
Well, I mean, this is first of all a question of the primary energy factor, so of the coefficient of performance of the heat pump and of the primary energy factor of the electricity it uses. So if you have a very efficient heat pump and you have a electricity mix in your country with a relatively low primary energy factor, then yeah, of course, this is a good approach to decrease the primary energy value of your nearly zero energy building.
Okay, thank you. Have all national members sent the national plan?
No, they haven't. Let me think. I have to take care that I don't mix it up with the cost optimality. No, it's about the nearly zero energy building, so I didn't follow it up to the last moment, but at the date where the plans were due, I think 2 countries had handed the plans in, and 2 months later, by February or so, I think the number of countries who had handed in the plans was something like 13 or so, so half of the countries. But in fact, I'm not aware how many countries have handed in the plans today. I don't know.
Okay.
But you can look it up on the website of the European Commission because all these plans are online.
Mm-hmm. Okay, thank you. Will there be any help support program from the European Union to implement the near zero energy buildings in the next years?
Not that I'm aware of. I don't know. I never heard about that. So in principle, it's a national requirement to look for the way how to achieve it.
Okay.
But maybe I can add to that, Fernando. So maybe I can add
Mm-hmm.
to that. When, for example, I mean, of course, the European Union helps to implement them, but not with direct support or something like that. But for example, we have the Intelligent Energy Europe program, a research program, which is very much dedicated to speed up markets for certain things. And during the last years, a lot of projects have been granted that deal with capacity building in different markets of the European Union towards nearly zero energy buildings.
Mm-hmm. Indeed. So probably there is something in the Horizon 2020 program.
Yes, exactly.
So maybe our audience can have a look. So just type Horizon 2020 and you will find the current calls, which are all open for the time being.
Yeah.
Okay, good. So a question related to the use of gas instead of electricity for instance, oven or other appliances. It seems that appliances are not to be included in the balance of the building, but is there any consideration on the use of gas versus electricity technologies?
No, so as I said, so I listed the parts of energy consumers in the building, so to say, which are included according to the EPBD. And all the appliances, as you said, they are not included, but in fact a member state would be free to include them in their national definition. So yeah, if they would do it, then they could also think about giving credits to things like they are mentioned in this question. But the standard approach, I think in almost all of the national plans that I've seen so far, really only sticks to the categories which are mentioned in the EPBD. So appliances are not in.
Mm-hmm. Okay, good. Another question or comment, I cannot see the link in the presentation and in the conclusions that near zero energy building is almost the same as passive house. If you use, for example, 50 kilowatt hours and compensate with on-site photovoltaics, for instance, 16 panels on a house, you have a near zero energy building house, but not a passive house, with even more comfort when using, for instance, a heat pump, including the renewable heat. I don't know whether the question is clear.
Yeah, so the link was made not on the level of primary energy, but it was made on the level of energy demand. So because we found that usually, so in the different climate regions we had, and also assuming the availability of renewable energy, the highest probability to achieve the nearly zero energy level was when having a very, very low energy demand of the building, which in most of the cases was quite close to what today is considered to be a passive house, which says that the heat demand should be lower than 15 kilowatt hours per square meter in a year. Of course, as I've presented, I mean that probably was a bit quick at that part. There are also options which are mentioned here by Hank that it could be a slightly worse, in quotation marks, heat demand, and when you have the possibility to compensate by PV where your building is, yeah, of course, then you can do that when you're in the comfortable situation to have this opportunity.
Okay. Yeah, so your questions are treated in chronological order, so if you don't see your question addressed, it's just because other questions arrived before and we are proceeding one by one. In case we cannot address them, you will receive a written answer and this will be published. Good. There is another question. It seems that you're relying on PV entirely when we should be focused on passive systems like insulation. Well, I think the question has been addressed. So first, going to the economic optimal with systems like insulation, and then the rest to be covered by renewables.
Exactly.
Okay. So probably the question was already answered.
Yeah, but maybe I can give a short answer to that.
Please.
We couldn't analyze everything in the project, obviously, because unfortunately the financing from the Commission was not endless for the project, as you can assume. And therefore, for the compensation and for the calculations we did, in fact, we agreed with the Commission that for this project we would focus on how much PV would you need in order to enter the area of nearly zero energy buildings. Of course, as I pointed out, other renewable options also could have been looked at in more depth.
Okay, good. There is another question. You have based your considerations mostly based on EU countries' findings. How your conclusions would have changed if non-EU countries would have been considered?
Well, in fact, I don't think, I mean, they would have, we already have quite a big spread of boundary conditions like costs, energy prices, interest rates, and climate all over Europe. So as you could see from the selection of cities that we took, we already have quite a big span that led us to these conclusions, and more or less they were the same for all of the different climates and countries that we looked at. So if it's really not totally different, like the Amazonas region or something like that, I think for most of the places in the world, the conclusion wouldn't have been so much different.
Okay, thank you. Another question on, well, basically how to alleviate heavy calculations on cost optimality. To give an example, in Malta, double glazing is very expensive to install and the energy savings are low. So why include this in a whole exercise of cost optimality? Are there some avenues to, well, to show the low-hanging fruits first and then other alternatives?
I mean, if, for example, we would have done the exercise that I presented for Malta, then probably we would have come to the result that, okay, if we would have known the Maltesian market better, then probably we wouldn't have taken into consideration the windows at all. So for the Malta example, when you are an expert for the Malta market, and upfront you know that this is not an option, you could have done the whole exercise without taking into consideration options for windows. So of course you are not forced to combine everything with everything as we did it in this project, but you really can use your expert judgment and your knowledge of the market, which will allow you in the end to decrease the number of options that you take a closer look at. But what usually is not recommended is that you do it on a measure-by-measure basis, because in many cases we have a multiplicative relation between measures. So for example, when you start with a boiler, it will save a lot, but when you do the insulation before, the same boiler will save you much less. So we totally focused on a package approach where we said, okay, when we combine this and this and this measure, what will be the result?
Mm-hmm. Indeed. Okay, good. I think there are a few more questions. So the point is whether we take 5 more minutes to address them orally, or we should adjourn here and give a written answer?
Okay, if it's just 5 minutes, let's do it, and it's probably most efficient. And I think it will people make more happy to get the answer right now than waiting for a
Okay.
written reply.
Okay, excellent. So let's go quickly through them. So is there a recommended path for national definitions to evolve? I don't know whether the question is clear.
Well, I don't think so. I think what really makes sense if member states use the template, which in the end reflects the requirements of the EPBD, to really think about all the different fields where action can be taken in order to improve the market conditions and the other boundary conditions for increasing the number of nearly zero energy buildings. So, but I think a very important aspect would be that a member state really seriously addresses all these aspects in order to come up with a complete strategy. That's probably the most important thing.
Mm-hmm. Okay. A question relative to monitoring. There will be a framework for this. Is it a static approach, not including the operation and maintenance, or there will be a dynamic approach, including the residents' behavior?
So this is, I think, the question if we are talking about theoretical values or real values that we will see in practice.
Mm-hmm.
Again, this would be something that is up to the member state because the EPBD allows that you do your energy evaluation, the evaluation of the energy performance based on a calculation or on measured values. Of course, I made a very close link to the cost optimality calculation, which is based on calculated values, but in principle, yeah, you also could think of evaluation procedures where real monitoring is going on. So yeah, the EPBD would leave this possible. So both is possible.
Mm-hmm. Good. There is a comment relative to the embodied emissions of the construction itself, whether they are accounted or not, or whether they should be included in the balance.
Yes, in fact, I think that should be done. And before we did the project for the European Commission, we did a project for the Buildings Performance Institute Europe, which was called Principles of Nearly Zero Energy Buildings. And one of the conclusions that we drew there was, in fact, that we think a future version of the EPBD should also include the construction or the manufacturing of the construction materials. And we would appreciate if this would be included in a future version of the EPBD. But introducing it today, I think would really be an overload for most of the member states. And yeah, there is nothing like a catalog usually available in a member state where you just look up, okay, this is the primary energy that you use for 1 kilogram of bricks, which would make the calculation easier, but there is quite some uncertainty about these values. But I still think we see already a development into this direction. I really could imagine that in some years science will have developed so far that, in fact, EPBD could ask to also include this into the total life cycle balance of the buildings and not just the operation.
Sure. Thank you. Very interesting. How would you see to increase the compliance with EPBD? Even in very tightened frameworks like Germany, ENEV, the compliance rate is not 100%. In Spain and Italy, EU Commission claimed that compliance with existing EPBD is very low and recast implementation jeopardized. EU asked to take severe actions.
Yeah, that's a very, very valid question, and we are also doing quite some projects for the German ministries here, and this is always a very hot discussed question. Yeah, I think the only way to do it is in some way introduce samples. So I don't think it's possible from an administration point of view to do 100% compliance checks. But yeah, in fact, as Thomas says, we also would appreciate, even in Germany, more checks on how much compliance we have in the field. So yeah, I think every member state in the end really has to find its own way to increase compliance, because yeah, climate targets are not helped by just achieving something on paper. So in real operation, the real operation is the proof of the pudding.
Mm-hmm. Thank you. Relative to a previous question about cogeneration, you replied as if cogeneration is considered renewable. Is it the case in general?
Well, there are different perspectives on that. First of all, I was only talking about the effect on the primary energy consumption. So when you, for example, take the Renewable Energy Directive, there is a formula that tells you how to calculate the share of renewables in case of cogeneration, and also in case of heat pumps. So yeah, cogeneration usually, first of all, only has a lower primary energy factor depending on which methodology you apply. But if your cogeneration only is made from coal, for example, then this is, of course, nothing that increases your renewable share. It, first of all, only decreases your primary energy factor, but that only would match one of the basic requirements that we have for nearly zero energy buildings, because it explicitly says that you also should have a significant share of renewables. And cogeneration is not per se renewable.
Okay, good. And I think we are close to the end now. This is more to ask your comments on the EU policy to 2030 that we knew yesterday. The efficiency on buildings and the general efficiency seems not to be present. Any comment to this? Opinions?
Yeah, in fact, I didn't have the time to exactly look at it, but I still hope that this is not the final word, because it's really, so what I read so far is really not in line with yeah, what would be necessary in order to reach the 2050 climate targets.
Okay, thank you very much. Okay, good. So I think related to this, there is another comment. What are the influences of the construction lobby in the general European energy policy? I don't see energy policy presented to 2030. So, okay, I think this question is already addressed with the previous one. So we will have time to further analyze and make a more solid opinion.
Yeah, exactly.
Okay, excellent. So thank you very much, Andreas, for this very intensive session. So it definitely was of high interest of the audience, as we spent practically almost 1 hour going through questions. So it shows the high interest of this topic. So we should definitely think about future sessions as soon as we have some news to communicate. Thank you to our audience for being so numerous and from so many countries around the world in this session today. And well, I give you the floor, Andreas, to close the session.
Okay, thank you very much to Fernando, and also thank you very much to staying with us for this session. And I hope you enjoyed it and you can use some of the information I told you in your projects and your practical life. So I just can tell you, so if you would like to see more details of what we did, because in fact it was quite a complex project, you can find the report on the Ecofys website and also on the European Commission's website. So thank you very much for your attention, and probably you will see and hear us again in the future. Thank you.